Hello everyone, this is Cameron Snow with Danomics.com. In this video, I'm going to be reviewing some of the data management tools that we're building into our new Flows toolkit. So let's get started. You'll notice that I've logged into the Danomics platform. To get started with the data management tools, we'll need to create a new flow. To do that, we'll say File and New Flow. And I'll give this a name. I'm going to call this first flow the log health check tool, and I'm going to hit OK. And you'll notice it brings up a new flow file type. So in this flow, we're going to focus on using our log health check tool. So to add that, we can either click New or Start Typing. And I'm just going to start typing here, and you'll notice we have log health check here first in the list. So I'm going to click Add. And this is a standalone tool type. So what that means is we only have this single block that we'll run. So let's start off going through this tool. So we have our LAS data set. So this is our wells here, and I'm just going to choose one of our standard demo data sets. This is an Alston Chalk data set. And we also need to put in some well headers here if we want to use the full functionality of the tool. So I'm just going to choose the associated well headers. And now we have a number of options here. So first of all, it says what checks do we want to run. It'll either say all except, or selected. We're going to run all of them, but I want to show you these other options here. So all except allows us to exclude which ones we would like to run, and then selected allows us to only run a single check. So if you're interested in a specific problem, like let's say you're only interested in knowing which wells may have an out of order depth step, you may, for example, just choose the ones that have the positive or consistent depth step. So you can choose these. What I want to do, I want to run through each of these very quickly so you'll know what's available. So first of all, does your file have a well header available? Simple enough. Does the API match the regular expression? So for example, is it 14 digits long in this case? Do we have a standard depth curve name? So in LAS standards, the depth curve is supposed to be labeled DEPT, so we will check that for you. We have the positive depth step, so are your depths ascending? Consistent depth step, do we have the same depth increment through all of these? Do the start and stop depths that are in the LAS header, do they match the depth curve? Does the step increment match what we observe? And is it a standard depth step, where standard is defined here in the menu parameter? So perhaps if you're working with a different tool set, you could define that differently. Do we have standard null values? Are the curves all null? Do we have data gaps? And do we have repeated sample values at either the top or the base of the well? So those are the options, but we're just going to choose to run them all on this database. And once we have this set up, we can hit the run button. So we're going to hit play there. And it'll go through a phase of initializing, then running, and then it'll say finished. So this typically should run fairly quickly. Probably the longest part of this will be the initialization for most of you. And so once it's run here, the output of this type will be here in the job log. So I'm going to click on this. And now let's walk through this. So what you'll notice here is it gives us an API number. And you'll notice this API number is repeated, and that's because it's repeated for each of the problems that are present. So we have our API number, and it's telling us, hey, we have data gaps for these curves. We have repeated sample values at the top of the logs for these curves and repeated sample values for the base of logs for these curves here. And we can see we have this for each of the API numbers, and then here at the bottom we have a summary, and it'll tell us you know, how many failures did we have. So for example, for our well header available, we had no failures. For our API matching the regex, no failures, et cetera, all the way down until we get to data gaps. And we notice that 25 of the wells have data gaps. 39 of the wells have repeats at the top of the logs for at least one of the curves. And 44 of the logs have repeats at the base. And so now we can use this information to perhaps then modify some of our curves. So that is the log health check tool. Now you may say, how do I address some of the problems that are brought up here? And the most common problem that we see are the repeated tops and the repeated tails. So to address that, we're going to create a new flow. So we're going to say File, New Flow, and we'll call this the, give this flow a name. So we're going to say Eliminate Repeats Flow. Okay, so for this flow, we're going to need 3 blocks. We're going to first need a log input block. Next, we're going to use the null repeated log samples block. And we're going to end this with a log output block. And so here in the log input, we are going to want to give this a name. So I'm going to choose the database that I just evaluated, and I'm going to choose to run this on all wells. And then I'm going to choose here in my null repeated log samples, I'm going to choose to operate on the gamma ray curve, and I am going to use the alias table, and I'm going to say, all right, let's eliminate anything with more than 5 repeated samples, and I want 0 tolerance on that. So what that means is it has to be an exact repeat. So it would have to be, for example, a value of 25, 25, 25, 25, and it would have to be at least 5 repeated values. And I'm going to do trims from both the top and the base. And then finally, I'm going to write this out, and I may call this something like trimmed top and base. And now, once again, I can hit the run button once I've set this up. And what this will do is it will eliminate repeats from the top and the base of each well for the gamma ray curve and other curves that are in the gamma ray alias type. Because this is a Python-based tool, and we can tell it's a Python-based tool because it has the little Python icon here, it will have to initialize the Python server, and in general, this will be the longest step in the process is the initialization step. Once this is completed running, what we'll want to do is we'll want to come back here to our log health check tool, and we can rerun the flow, and we should notice that the repeats have now been taken out of the for at least the gamma ray curve. One thing to note is that you can put as many of these null repeated log sample blocks as you want inside of a flow. So for example, you might want to have multiple of these for each curve type. So you may want to have one for gamma ray, one for density, one for neutron, one for resistivity, and so on. And that will allow you to completely clean up your log database with respect to that repeated tops and base errors. Okay, while this is running, I want to show you the next tool type that we have available, and this is the Mnemonics tool type. So we're going to start here. We're going to say File, New Flow, and we're going to say Mnemonics Analysis for the name. And we're going to hit OK. And we're going to start off, we're going to have a new, and let's say Mnemonics Analysis. And we'll notice that when we add this, we have a little error message here and says, we expect to have LAS files. Here's our input. And what that means is we need to give it a log input here. So let's assign that log input, drag it up above, and we can either use that database we just wrote, or we can use our original database. And we're going to hit the play button here. And what this tool is going to do is it's going to give us a summary of all our curve mnemonics so we can understand what's available. When this runs, once again, down here in the jobs log, we'll have this icon here. and what we can see is the output. It gives us a number of curve names, and then it tells us how many of those there are and what they're alias to. And it does this in descending order. So for example, we can see the depth curve, DEPT. There are 46 wells. There are 46, with that curve. And, this curve is alias to depth, of course. That is an alias. We can see that we have our induction log, our deep induction log. This is present in 43 wells, and this is aliased to the res-D curve mnemonic. This continues, so on and so on, until we get down here. And here we can see we have a log that's not alias. And this is our ROP curve. This is the rate of penetration. This is not a curve that we typically use in the petrophysical analysis, so it's not present in our alias table. If you think that you do have some missing data, like for example here we have the ASFL1, so this is a shallow focus log, and we can see that we have a 1 on here. This is probably a log that was that was duplicated at some point, written out, read back in, etc. And so that mnemonic is not in the database. So if you notice this curve was missing, you may want to go add that to a custom alias table. And this allows you to get a feeling for how much of the data the alias table is helping you read in and allowing you to discover which mnemonics you may do some more research on. Okay, so those are the 3 tools. Now, the last thing that I wanted to show you is, this is our Eliminate Repeats is finished running now. And so what I would like to do is circle back to this log health check tool. And now I'm going to pull in this this database that I've just created, and I'm going to hit the run button here, and this will be a very quick operation. I just want to show you this to show you that the gamma ray has indeed been cleaned up here. So I'm going to open up the log health check tool, the initial one, and we can see that for about the for this first well on the list, we do have some of the aliases that are repeated. So for example, here in this well, we have a gamma ray that has been repeated. And when we open this up for the next well, so let's go back and let's check out that API number. That is this API where we had repeats for the gamma ray. So let's just do a search here for this, and we can now see that we no longer have the gamma ray included in the repeated tops or tails. So that is one step of the cleanup. Of course, you probably want to go through and include several of these eliminate repeat blocks. And remember, to do that, you just need to come over here and you can say, null repeated samples, and you can just put in several of these blocks as needed. So we have one for gamma ray. We could also have one for our bulk density. We can have one for our neutron. We can have one for our resistivity. Maybe we have another one for our sonic logs. And so, now when we run this, it is going to run it for each of these curve types. And I would encourage you to do this for each of the aliases that is in the alias table, as that will result in a very clean database. And once again, the process for running this is just to hit the run button here, and that'll execute very quickly. And remember, you don't have to set up a new flow for each database. These flows can be reused. All you need to do is choose the database that you want this to act on, and then give it the appropriate output name. So if I wanted to run this on a different database, I could just select perhaps, one of my, let's say my Bakken database, and I could give that the appropriate name. So, maybe I'll call this, like Bakken cleaned. And that's all you would do to run that on a different database. All right, so I hope this video was useful to you. These are just some of the new tools that we have added. So we have the log health check tool, we have the curve mnemonics analysis tool, and we have this tool to eliminate repeated samples at the top and base of logs. Needless to say, we're going to be building out a whole environment of tools around helping you clean your data, and this will include things like giving you the ability to fix maybe some of the depth problems that you may have noticed from the log health check tool, give you the ability to remove bad curves, rename bad curves, null out bad data, etc. So we're going to build out a whole ecosystem of tools to allow you to get your data interpretation ready as quickly as possible. All right, so I hope this has been useful to you, and as always, if you have any questions or need any help, you can always reach us at support@danomics.com. Thank you very much.